So if you apply deformation boundaries, so I think we need some basic concept regarding the deformation boundaries. Usually if you apply deformation boundaries, which shows how much deformation is going towards the opening. So this is boundary, this is excavation, actually this is excavation boundary. So if I want to study the deformation, how much deformation is going or undergoing from the original boundary to the opening, that is we have to study. That is very important in the case of rock mechanics analysis, in a tunneling or in this case. So I will tell you one how the movement is occurring from the boundary. Just we have to use the scale factor, actually it's in relative stages now. Then select scale factors. So in scale factor, which is only 1, in if you change from 1 to 100, it gives 100 times of the deformation. So let's observe the how much deformation is causing. Let's change to 100, then apply. So you can see the deformation from top and bottom and side. There is a lot of deformation. That is 100 times from the original. So we are studying the boundary deformation. So we are estimating how if there is a 100 times of deformation, how much deformation is coming from the original position. That is the study of deformation boundaries. So if you apply deform mesh, it's a good result. It gives a clear picture of how the entire rock mass has moving towards the opening. It gives information and deformation meshing with regarding deformation boundaries and deformation mesh. That is about deformation and deformation boundaries. So we have studied about. Then I think it's better to remove it. Okay, remove the deformation and deformation boundaries. Okay, let's moving on to the bolts. Okay, let's moving on to the bolts. Then select display options. Here you can see support. So bolts, you can see here bolts and bolt numbers and bolt elements. Generally if you untick, then it won't show the bolts here. If you tick the bolt, you can see here bolt. Likewise select all of them. In stage 1, select bolts and apply. Then here in stage 1 there is a in stage 1 bolt, and stage 2 and stage 3 already applied. Let's analyze how the bolts and the how many number of bolts are there, then analyze by that way. But for that, so you have to go for display options, then select bolt number. Here you can see there are 8 bolts are there. Okay, done. Let's select here display option and bolt number and apply. Here you can see 1 2 here 4 bolts. Likewise here also we have to apply same and bolt numbers. In 3 stages we are applied and analyzing. Okay, here there are 12 bolts. Okay, the next step is then again go for display options. You can see bolt elements. Select bolt elements. It will show here you can see one crosses on the bolt, which gives the information of discrete numerical representation. It's a discrete representation, numerical representation of a real world of rock bolt. Generally, it is used for analyzing how bolt resist force and contribute to the stability of excavations, such as in tunnels. Okay, which is resistance forces. So deselect it. Okay, then I want to draw the graph related to axial force and the these bolts. So for that, if I want to just I want to only select one tab here for the clear information, for the clarity and vision. Then pan. Okay, then remove. Okay, right here you can see graph. Okay, graph bolt data. Okay, then select this bolt and first bolt and second and the third or fourth, whatever it, that is your wish. Then right click. Here you can see graph selected. Okay, select and graph selected. So I want to make a graph in stage 1 or stage, you can select stage 1, in stage 2 or stage 2, your wish. Then you can select all of them, you can go with that. Then I want to select stage 1 and 2. Just let's see how the graph is plotted in graph 1. I selected only the stage 1, then click on plot. Okay, graph is plotted. Okay, I selected 4 bolts, so 1 2 3 bolts. Okay, these are the here you can see the bolt stage 1, this is stage 1, and there's a number of bolts 1 2 3 4, and these are the stage, these are the bolts, number of bolts are 4, and in stage 1 the graph are plotted between axial force and distance in meters and meganewtons. Okay, yes, you can see bolt 1 cable tensile capacity is equal to 0.1 meganewtons and 0 residual capacity. This is the way to plot the graph between the axial force and a distance. So then go for the initial stage. This is stage 1. I think we have done the analysis of principal stresses and stress trajectories, and one tool, that is a window tool, which gives we can analyze simply by at a time all stages, and strength factors, total displacement, and rock bolts. These is the information regarding of entire this experiment. I think it is fruitful for you. Thank you.